see one of the IPC mechanism, that is pipe. That is pipe. Okay, that is pipe. First we will see the overview of pipe, followed by the real one coding example. Okay. So now, what is pipe? We know we are sorry. Before that, pipe and FIFO, these are the these two are the FIFO also comes under one of the IPC mechanism. Okay. So now, pipe and FIFOs. First, read the definition of the pipe. Okay. Huh? First, pipe and FIFOs. FIFOs also known as named pipe. Okay. FIFOs also known as named pipe. Okay. So what they are providing? Sorry, pipe and FIFOs provides a unidirectional inter-process communication channel. Okay. First, read up to here. Pipe and FIFOs provides a unidirectional inter-process communication channel. Huh? So what is unidirectional? Let's say is a pipe. One second. Okay, I'll explain here later. Okay. Firstly, pipe and FIFOs provides a unidirectional inter-process communication channel, and a pipe has a read end and write end. Okay, a pipe have two ends. A pipe have two ends. Okay, what are the two ends? One is read end and second is write end. Sorry, second is write end. Okay, so write end data, we have to write end is used for to write the to write the data into the pipe, and read end is used for to read the data from the pipe. Okay. Huh? Let's say I will explain here. Pipe first. First, what is this? Pipe provides a unidirectional provides a unidirectional inter-process communication. Okay, unidirectional is nothing but only one directional. It is only one directional. Unidirection means only one way. Unidirection. And first line is that one. Pipe provides a unidirectional inter-process communication channel. Okay, we got it. You got it right. What is unidirectional? Next, a pipe have two ends. Let's say a pipe have two ends. Here one end, here two ends. Okay. Now, what is the purpose of two ends? One end is right purpose, right end. Second one is read end. Second one is read end. Okay. Now, right hand is used for to write the data into the pipe. Okay. Read hand is used for to read the data from the pipe. Okay. So this is called pipe definition. I hope I hope this is clear. See, let's say, and one more thing, if you want to go in depth about to overview, just to type man 7 pipe, sorry, just run this command man 7 pipe, you will get the overview of pipe. Okay. Now what I am going to tell is, what I want to tell is, pipe, sorry, this pipe is used for only relative process. It is used for only relative process. Relative process nothing but, let's say, this is a y, this is y plus 1, this is y plus 2. So you already know what is y plus 1, y plus 2 and all. Let's say this is y plus 3. See, this pipe is used in only relative process. In the sense, if one second, if this y process wants to communicate to this y plus 2, or this y plus 1 wants to communicate to y, so like that. So this all y plus 1, y plus 2, y plus 3, this all are parent process is only one. The parent process is only one, that is called y. So this IPC, this pipe is used for only, this IPC is used for only relate to process communication. Okay. Huh? Now, what again I am telling, what is the purpose of using pipe? What is the purpose of using pipe? Huh? The purpose is to send data, between one process to another process, and those process are those process are related process only. Okay. Huh? Pipe. And coming to next, pipe have two ends. What are two ends? One is read end and second one is write end. What is the use of write end? Huh? Write end is used for write the data into the pipe, and read end is used for read the data to the end. Okay. Huh? Let's say now we will see the task. Let's see the task here. Parent process need to scan the data from the user. Okay, parent process need to scan the data from the user, and it has to put into the pipe. Okay. And child process read the data from the pipe and print it into the screen. Okay. Please read the task carefully. Once again, parent process need to scan the data from the user and put it into the pipe. Okay, that is the responsibility of parent. Now child process, what he has to do? Child process has to read the data from pipe and put it into the screen. Okay, I will explain here. Diagrammatically I will explain. Parent process is there, is nothing but y. Child process y plus 1. Parent, this, let's say in between, one second. Parent process wants to send data to child process. For that we are using pipe mechanism. Okay. Now coming to the task. The parent process has to read the data, from keyboard, and put it into this pipe. Okay, now next, child responsibility. Child has to read the data from the pipe. And put it on the screen. Okay, this is clear, right? The task what we are going to do. Okay, so before okay, now this is the communication channel, right? This is a communication channel between the parent process and child process. Okay, so with respect to real time, with respect to microcontrollers, I will tell you an example. Like, let's say you have one microcontroller, and one GPS sensor is there. GPS sensor is there. How to read this data from this GPS sensor? By using UART. So you already know what is UART. Okay. So here in this scenario, one second, in this scenario, how UART act as a communication channel between microcontroller and GPS, right? With respect to microcontroller scenario. So like that, with respect to OS, this pipe act as a communication channel. This pipe act as a communication between the processors. I think, is it clear, right? Now, how to create the communication channel? How to create pipe? how to create pipe. Till now we will discuss the theoretically. Now how to create pipe and what is the prototype, what is the header file, what are the arguments, we will see those and all. Okay, for that we have to open man page. Man to pipe, sorry, to use space here. Yes, first header file is unistd.h. Okay, now pipe, like there is a two functions are there. There are two functions are there to create a pipe. One is pipe and second one is pipe 2. Okay. Um, for now we will go with the pipe function. Pipe, sorry, it's not a function, it's a system call. We already know, right? It's a pipe, man to pipe. It's a system call. Okay. So for now we will go with the pipe system call. In next lecture, I will discuss about pipe 2 and what's the difference between pipe and pipe 2. Okay, now what is the return type? Return type of this function is int. Okay, now what are the arguments we have to pass? See, I think this is very new type of argument we have to pass. I think, like, what the argument is, what is the argument type. First see what the argument type is, integer. Okay, what the argument type is, integer. But see here, we have to pass a integer array of size to address, integer array of sorry, first see this pipe fd, what is that? This is the array, this is the array of which type? Integer type, right? What is the size? 2. Okay, so now what we have to do is, for pipe function we have to pass address of array of integer size of 2. Okay, so 1 second, I will tell you, I will show you one example. Let's say if prototype is, let's say now prototype is int abc int style. So like that is there. So what is the return type? Integer is the return type. And what you have to pass? Integer pointer address, right? Now what's the return now what is there? Int pipe, int p, like let's say what they took, pipe is a variable name, we can say, let's say p of 2. This is there. So what, so this is the prototype. What we have to pass? We have to pass array, integer array of size to address. Okay, I think if you see the code you will get understand. Okay, 1 second. Okay, now so that is the argument. Now what is the return type? We will see the return type is integer. Okay, that return, 1 second, here on success what it will return? 0 is return, means on success is nothing but if pipe is created successfully it will return 0, otherwise it will return -1. Okay, that is the return type. We will check now. Okay, I hope the task is clear, and I hope you got the system call how to create. Now we will start with the coding. Actually I created one header file for common. We will use that header file for all codes. Okay, so that 1 second. No need to include every file. Instead of that we can create one common file and we will include that file. Okay, so this is the common header files I created for one header file. Now we will write the code pipe1.h, and we have to include common header file here. of 2. Okay, now I am creating pipe. What we have to pass? We have to pass an integer array of size 2, that is called p. Now that return type is storing into r. Now I am checking return type. If r not equals to 0 means if unable to if pipe is unable to create a pipe, sorry, if unable to create a pipe, what we have to do, we have to write printf statement like pipe is not created, pipe is not created, and we will return the from this code. Okay, next printf pipe created or else. Okay, now this this is for pipe creation. Okay, now we have to create a one child process, right? uh, with respect to task. Now I am creating if fork double equals to 0. By using fork I am creating. Now tell me one basic question, like who will execute the if body, who will execute the if body, and who will execute the else body? We already know, right? If body is executed by child. Why means in fork system call, in fork will return 0 in child process. Okay, so that's the condition we written, right? Fork double equals to 0. So the if body is executed by child. Next else part will execute by parent. Now clear, right? Now what's the parent task? What's the parent task? See, what's the parent task? Parent process need to scan the data from user and put it into the pipe. We will write. Okay. So it has to scan data uh, from user, sorry, from keyboard.user. So that's why I'm creating one character array, and I'm writing one printf statement like I am asking enter the data. Next I'm using scanf. I'm using scanf function to scan the data from keyboard. Okay, till now it's completed. Now one second. Now what's the parent task? It has to put data into the pipe. Huh? No, okay. Before that I want to discuss one thing. Right? Yeah. I want to discuss. So this is the one second. This is the prototype. So this is the prototype. Okay, so here p, so here p, what is the p? P is a array of size 2. So what is that? What are those elements? P of 0 and p of 1, right? Now we already discussed, right? Pipe has two ends, huh? Right, one is read end, one is write one. Okay, now this p of 1 is there, right? This p of 1 refers to right end, p of 1 refers to right end. Okay, and this p of 0 comes for read end. Okay. Now in the code, this is clear, right? We are passing array of pointer array, sorry, integer array, the size to that first element refers to p of 0 refers to read end and p of 1 refers to write end. Okay. So now we have to pass like that only. So for write function, you already know what is the write function, what are the arguments. So I'm not explaining those things. For write function, we have to pass three arguments. One is file descriptor. Next, what is so next two argument is data. Next, size of that data. Okay, you already know this thing. It's not explaining. Okay, now so this is completed. Parent task is completed. See, parent task is to scan the data and it has to write data into the pipe. Okay, for that one, see, p is a pipe, right? So that's why we have to pass pipe descriptor here, first argument. Second one is data, third argument is size of data. Right, now now child task is it has to read the data from the pipe. So it's like read in the sense we have to use normal read function, write function, that's it's enough. Okay, next, read, which descriptor we have to use? P of 1 descriptor, p of 0, sorry, p of 0. Next, address we have to pass to store the read data. Next, size of s, you have to tell read this many bytes. Next, after reading that one, what we have to do? We have to print on the console by using printf statement. Okay. I hope that's it. Now, for better understanding purpose, I am adding one printf statement like printf child process child. So let's say in child. Like that in parent process also. Now I will execute. Let's see if any errors are there or not. Yeah. Yeah, size of st here. Now I am executing. Sorry, sir. Okay. It hasn't created a .c file. Okay, 1 second. Okay, clear. Now 1 second. Yeah, we executed successfully. Now we'll run the code. Before running the code, I will open the code in one terminal for better understanding. What we got, pipe is successfully created, so that's why we got pipe created. Next, we next in fork function, sorry, if body, we got in child and in parent. Now parent is waiting for parent is waiting for to scan the data, right? Right. Now if you scan, or after that if you put that into pipe, the child has to read. Okay. Now one more thing I want to tell, if pipe is empty and you are trying to read that from pipe, sorry, if you are trying to read, so what will happen? uh, you have, that read function will act as a blocking state. Okay, the read function will act as a blocking. It will block until the data has to come into the pipe. Okay, so I will explain in diagrammatic. Okay, this thing. Okay, now we have to pass some data like hello one. After that, here we are passing the data by using scanf and this print from child. Okay, I hope the task is clear. I will explain that thing one. Okay, this is the code. Now I will explain one disadvantage or anything future we have to say. Let's say this is a pipe. Read and write. See, in our example code, sorry, in our example task, see the child process is trying to read the pipe, right? Is trying to read the pipe, but pipe is empty. Pipe is empty. Okay, what will happen? What will happen? The code is in, sorry, this line is there now. So this line act as a blocking. This line act as a blocking until if you write data into the pipe by, that is 33 line. Okay, that is 33 line. Okay, so until if you write the data into the pipe, the read is a blocking. And now one more thing. So one thing, first again I am telling, first thing, if pipe is empty, if here I will write for clarity. If pipe is empty, if pipe is empty and you are trying to read the data, so the read function will act as a blocking, act as blocking. Okay, this is one thing. Next, if pipe is full and you are trying to write it, this situation also write function act as a blocking. Okay, so these 2 points related to pipe. Okay, so I hope you got it little bit idea about pipe. If you want to learn more, just to check overview of pipe by using man 7 pipe.
Love our content? Hit subscribe for more awesome videos. We'll see you in the next one.